Alright guys, so I'm going to finish up this problem we didn't get the chance to finish during lecture. And well, instead of doing the whole problem, you have everything on your notes. I'm just going to take it where we left off. So, which is the part in which we set up the integral and we try to, not set up the integral, rather we got a new integral that we integrate using the U-Substitution method. So at this point, notice that in the numerator of the integrand, we have what would work very well as the as the du for u equals the quantity inside of the radical here, So, and this is what we got to do in lecture. So in lecture, we got to the point in which u equals to 2 minus 2 sine theta, and du equals 2 minus, or actually 2 negative 2 cosine theta d theta. All right. However, when it comes to evaluate integrals with limits, rather like from 0 to 2, like in this case, definite integrals are called. I kind of forgot the word for a second. So we need to change the limits of integration. And yes, I'm going to do what we did in lecture before. I'm going to do it again just so you can see what the issue was when we got to that point. So that's 2 minus 2 sine of 0 and 2 minus 2 sine of 2 pi. So the issue that we ran into when we were in class, so sine of 0, which is 0, so 2 minus 0 is 2, and sine of 2 pi is also 0, so 2 minus 0 is also 2. So we got to a point in which the integral gets evaluated from 2 to 2. Well, the issue here is that when the limits of integration are the same, well, the value of the integral is 0. Alright, because there's no change from a to b. We are essentially stationary. We're not moving at all. And well, that doesn't necessarily, that's very inconsistent rather with the picture that we have, because we're starting here, we're going around. Yes, we get back to the same point. However, we're moving some distance, and that distance is definitely not 0. So instead, what we're going to do, we're going to redefine the limits of integration. So what we're going to do this time, we are going to go around half only, and we are going to do this instead from negative pi over 2 to pi over 2. And we are going to multiply this by 2 because by symmetry, this is the same length for the remaining part of the cardioid here. All right. Yes, in class we also tried to do 2 times from 0 to pi, but it turned out that 0 and pi gives us 0 for sine, and we get the same situation. So for this time around, well, we're going to do a negative pi over 2 to pi over 2. So instead, so actually let's scratch this part. We're not going to need it. And 0 to 2 pi. Oh, wait a minute. No, not 0 to 2 pi. It's the integral from negative pi over 2 to pi over 2. All right. So we're going to do that instead. And that times 2. And 2 cosine theta. And 2 minus 2 sine theta. D theta. And let's do the U sub again, just so we can get everything together. 2 minus 2 sine. The derivative of negative sine, it's actually cosine, by the way. Okay, the derivative of sine is cosine times 2 negative 2 cosine theta, never mind, d theta. And then now we may evaluate. Okay, I'm going to go in slow motion here. So u at the lower limit, which is negative pi over 2, that is 2 minus 2 sine of negative pi over 2. Okay, but what is sine of negative pi over 2? Sine of negative pi over 2, it's, well, number one, you might want to use the even or odd properties of trigonometric functions. Sine of a negative angle, the negative sign is taken outside, making this positive 2 plus 2 sine pi over 2. And sine of pi over 2 right here is 1. Leading us to 2 plus 2 times 1, which is 4. So that's the lower limit. Let's do the upper limit. Pi over 2. Let's see. So 2 minus 2 sine of pi over 2. But again, in this case, this is 1. So this is going to give us 2 minus 2 times 1, which is 0. All right, now for the compensation here, notice 2 cosine theta d theta. This requires a negative, provided we multiply 1 outside. And when we evaluate this integral, this will be negative 2 integral from 4 to 0. I know the upper is smaller than the lower, but again, you can reverse the order of the limits provided you change the sign of this one. But I'm going to leave it like this, it's fine. So that's going to be du over the square root of u, which is negative 2, the integral from 4 to 0, u to the 1/2 in the denominator, du. And let me go over here to continue the expression, to continue the problem. Negative 2 integral u to the negative 1/2, 0 of 4 to 0 du. And let's integrate this using the general power rule. Negative 2 u to the 1/2 over 1/2 from 4 to 0. Dividing by a half, it's the same as multiplying by 2. So negative 2 times 2, back to radical. And that's going to be negative 4 square root of u from 4 to 0. And we're just a couple of steps away to finish this one. Negative 4 times the square root of 0 minus the square root of 4. The square root of 0, which is 0. And the square root of 4, which is 2. And 0 minus 2, which is negative 2, times negative 4, that's going to give us 8. And that's final answer. Alright, so this is the end of the problem. And by the way, this was the end of the section. Alright.